Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about several rules that are developed in order to help you speed up the process of finding the derivative of a function. And recall that in section 3.2, you have seen how derivative of a function, so derivative of a function is f prime x, and this can be obtained by implementing the idea of limits. So what it means here is you can find the derivative of a function by considering limit h approaches 0, f prime x, f x plus h minus fx over h. So you can find the derivative by implementing this idea of limits. And in many circumstances, which you will see later on, there will be a lot of complex functions where this method given here is going to be tedious and cumbersome to be applied. And so that's why in this video, we're going to talk about some of the rules that can be used when you want to find the derivative of a function. So we are not going to use the idea of limits. Instead, we'll just focus on implementing these given rules here. Okay, let's talk about the first rule. So here we have a function that is just a simple constant. So function fx is just a constant. Therefore, the derivative of a constant is going to be equal to 0. Now, in this second rule here, we have a function that looks like this, which is x to the power of n. And so the derivative of this function is going to be simply written as n. So n here comes from the exponent on this part. So we consider n. And then x here will have an exponent that is reduced to n minus 1. So you multiply them together. The third rule here is when you have a function that is made of by multiplying one function with a constant. So c is multiplied to c is a constant multiplied to a function, and you are interested to find the derivative of this function. Well, what you can do is you can consider taking out the constant. Since this is a constant, you can take it out, and then you can focus on finding the derivative of function fx. Once you got the answer, you can just multiply them together. Now, in the fourth rule given here, you can see that our function is made of by adding two different functions. And if you are interested to find the derivative of this function, you can do it separately by considering the derivative for fx. And then you can go on and consider the derivative for gx. And then the answers can be added together at the end. In a similar manner, this is the same process if you have a subtraction going on here. So here we have fx minus gx, and in order to find the derivative of this complex function, what you can do is you can consider them separately. This is the derivative for fx, and this is the derivative for gx. Once you got the answers, you can subtract them with respect to their fx minus gx, yeah? Now, if you consider rule number 6, this one here we have the complex function, which is made of by multiplying two functions, fx and gx. And the derivative of this function is going to be obtained using two simple steps. So the first step is for you to maintain fx. You maintain the function as given, and then you find the derivative for gx. So the result will be multiplied together. Now, in the second step, you maintain gx as it is, and then you go on and find the derivative for fx, and the result will be multiplied together. And finally, this here will be added. So the results of this first step and the second steps will be added at the end. And it is also normal that this process here is given a different notation, and the notation is fg prime plus gf prime. So f here means you maintain the function fx as it is. G prime means you have to find the derivative for function g. And similarly for this one, g here means you maintain the function gx as it is, and f prime means you have to find the derivative for function fx. And once you've got that, you just add the results together. Okay, so this notation here is a bit simpler compared to this one, and it is up to you to choose which one you are comfortable with. Okay, now if you look at the next one here, this is rule number 7, and you can see that the function that we have here is made of by dividing fx with gx. So you divide fx with gx, fx over gx. And for this reason here, this is the formula that you can use in order to find the derivative of this function. You can see what is going on here. This is maintaining gx. This is finding the derivative for fx. And you multiply the results together. Next, this is maintaining fx, and this is finding the derivative for gx. And then you multiply the results together. And so don't forget, this will be a subtraction process after that. And here you maintain gx and you square it. Okay, and the process here sometimes is simplified by using a different notation, which is gf prime minus fg prime over g squared. And again, it is up to you to choose which formula that you are comfortable with to work on, either this one or this one. It doesn't really matter. Okay, so now in this part of the video, I'm going to show you how the rules given in this page are obtained. So it doesn't just magically appear, it comes from somewhere, obviously. And for that purpose, I'm just going to illustrate two rules. And the rules are the first one here, which is how do you obtain the derivative for this function is 0. So how this answer comes into place. And if you have fx plus gx, how do you find the derivative of it given by this formula here? So that is rule number 1 and rule number 4. So I'm going to demonstrate how you can get the formula for this rule number 1 and rule number 4. Yeah, and the idea is you are going to go back to the definition of derivative, which you have seen in section 3.2. So the basic idea comes from the definition of derivative, which you have already done in section 3.2. So this idea can be implemented to prove other rules, for example rule number 5 or 6 or 7, but they are not shown in this video. And if you are interested, you can try and do it on your own. Okay, all right, let's begin with the first rule given here. So the first rule is about proving that when you have a constant, the function is a constant, the result that you will get is equals to 0. The results of the derivative is going to be equal to 0. Okay, so now let's start off with the definition of derivative, which is limit h approaches 0. Here we have fx plus h minus fx over h. So here, according to what we have, you need to substitute x plus h into the function. But notice that in this function, there is no x. Therefore, if you substitute x plus h into it, really you cannot substitute anything into this function because this function is a constant. Therefore, this here, the result here is going to be equal to c. So the result here is going to be equal to c because there is no position of x in the function where you can substitute x plus h. Okay, and what is the value of fx? So fx is equal to c. So again, we substitute c into this position. This one is over h. Next, what we have is we have 0 over h. and 0 over h can be simplified to having value of 0. And we have seen from the law of limit, if you can't recall what's going on, you can always go back to the law of limit. We know that if you have a constant, 0 is a constant here, the law of limit is going to be equal to the constant itself. So the answer is going to be equal to 0. So there you go. This is the derivative of function fx equals to c. So that's why the answer that you get over here is equals to 0. Alright, now let's move on to the next part, which is to prove that if you have this function and you want to find the derivative of this function, the result is going to look like this. Okay, right, so let's move on to the next one here. Okay, so here I have fx plus gx, and in order to simplify the process, I'm going to start off by letting the big F equals to the small f plus gx. So I'm going to let the big fx here equals to fx plus gx. Okay, so now following the definition of derivative. Okay, so this is what I'm going to do next. I'm going to follow the definition. Therefore, f prime x is equal to limit h approaches 0, the big F x plus h minus the big F x over h. Okay, and this is equal to limit h approaches 0. So what is x plus h? We need to substitute that into the function. So this is the big function f. I'm going to substitute x plus h into x. So that will be f x plus h plus g x plus h minus, what is big fx? Big fx is this one here. So minus fx plus gx over h. Next, what we can do is we can rearrange the items on the numerator. So that will be limit h approaches 0, fx plus h. So here I'm going to write down minus fx, and here gx plus h minus gx. So I'm just rearranging the items here, okay, accordingly. Okay, right, and based on the law of limits, you can actually consider separating this part and also this part. Okay, so that's what I'm going to do next. Okay, I'm going to write down this in terms of limit h approaches 0, fx plus h minus fx over h plus limit h approaches 0, gx plus h minus gx over h. Alright, and we know that this one here is the definition of f prime x. So this is the definition of f prime x, and this is the definition of g prime x. Okay, so here I'm going to write down is equal to f prime x plus g prime x. So this is the formula to find derivative, right? So this is the formula to find the derivative for function f, and this is the formula to find derivative for function g. And f prime x is equal to d dx fx, yeah? So this is what it means. And g prime x is also similar to d dx g prime x. So this is the result given by this rule number 4. And there you go, you have been able to prove using the definition of derivative that when you apply the idea of limits, you will get this answer here. So the rules come from applying the definition of derivative that has something to do with implementing the idea of limits. Okay, all right, that's all for now. Thank you very much for watching.